All right, guys, let's go over your study guide and get ready for this test. 12 cards are numbered 1 through 12. 12 cards numbered 1 through 12 are shuffled together. A card is drawn at random. Find the probability of the following event. One thing that we haven't looked at a lot is this, and that means the probability of less than 5. This is just asking you what is the probability of getting a number less than 5. So when you see it written like that, that's just a way to ask that question. Okay? All right, so this is one event. One event. So we're going to use our simple bridge. And these are numbered 1 through 12. So I'm going to go ahead and just write my cards up here. Just in case I need them for something. Go ahead and put my cards up there. And I need a number less than 5. So here are my numbers less than 5. So what do I want? I want the number 1, the number 2, the number 3, and the number 4 out of all numbers. That is 4 numbers out of 12, which when simplified, if I put that into my calculator, we're not going to get overwhelmed with the math. Here's my N over D button right there. 4 twelfths. That simplifies to 1/3. Use my conversion key. That gives me 0.33 as the decimal. And I know that I moved my decimal 2 places to the right, and that's 33%. But again, you can multiply that by 100. And this 33 that's sitting right here is your percent. And the likelihood of that happening would be a small chance, because we don't ever know what the multiple choice answers are going to ask us. Rebecca and Lauren are playing a game. Draw a card at random from 8 cards numbered 1 to 8. Rebecca needs to draw an odd number to win. Lauren needs to draw an even number to win. Okay? So Rebecca needs an odd number. So she needs a 1, a 3, a 5, and a 7. Lauren needs an even number, so she needs a 2, a 4, a 6, or an 8. How likely is Rebecca's chance of winning compared to Lauren's chance of winning? Well, Rebecca's chance of winning is 4 out of 8, which is 1/2. Lauren's chance of winning is 4 out of 8, which is 1/2. So they have an equally likely chance of winning, because unlikely, certain would be 100%, and that wouldn't work. And so equally likely is a 50% chance of winning. So that is the answer. What is the probability of spinning a 1 on both of the spinners? Both right here is telling me that I'm going to need to use my compound probability, because that is 2 events. This is 2 events. Okay, so what do I want on the first one? I want the number 3 of spinning a 1. The number 1 out of all numbers. And the second time, I want the number 1 again out of all numbers. There's 1 on the first spinner. Something under my paper. 1 out of 5, and there's 1 over here out of 4. And remember, when we have multiple events, we multiply. So 1/5 times 1/4 is 1/20. Okay, so 1/20. Now let's go ahead and change that to a decimal. It's 0.05. Move that decimal 2 places to the right, and that's 5%. Or I can multiply by 100 and get 5% there. And so we're going to say that's unlikely. Unlikely. All right. What is the probability of spinning a sum of 3 when spinning both spinners at the same time? Now, when you're trying to get a sum on those spinners, and we're spinning both spinners at the same time, what I need here are the combinations. All right, so let's... I need combinations. I'm going to put a little star right here that says C back. And we're going to turn this over because we're going to make a two-way table. We're going to do a table to solve this one. We're going to do a table to solve this one. So we've got spinner 1 and spinner 2. Right? Spinner 1 has a 1, 2 2s, and 2 3s. It has a 1, 2 2s, and 2 3s. Spinner 2 has a 1 and 3 3s. It has a 1 and 3 3s. So now I'm going to fill in my combinations. A 1 and a 1. All right, so I have all my combinations filled in right here. And my question says a sum of 3. A sum of 3. So look again here. So I put in my combinations. Now I'm looking for a sum of 3. 1 plus 1 is not 3. 1 plus 3 is not 3. So if I look down through here, I see that 2 plus 1 is 3, and I've got another 2 plus 1 right there that would give me 3. Okay? Well, I also need to be aware of how many total combinations I have. And all of my combinations are right here. The total number of, or the sample space. If you remember us talking about sample space. The sample space or my total outcomes are right there. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 2 out of 20 is how many is the probability of getting a sum of 3 when you spin both spinners. So 2 out of 20, when I put that in here, I'm going to make sure y'all can see my paper. Okay, put that in my calculator. That simplifies to 1/10. I hit my conversion key, and that's 0.1 as a decimal. Multiply that by 100. That is 10%. It said show your answer as a percent. Okay, so again, looking for that sum, looking for that, the combinations, and I will go ahead and say you have a question like this on the test. You need to make sure you know how to do that table. Miss Ellington rolls a number cube, tosses a coin, and chooses a card from 2 cards marked A and B. If an even number and heads appears, Miss Ellington wins, no matter which card is chosen. No matter which card is chosen, this sentence right here tells me that this event, we don't even have to think about. We don't even have to think about that event. Okay? because it's irrelevant. It doesn't matter which card is chosen. She can choose A or she can choose B. If these two things happen, if she gets an even number and heads, she's going to win, no matter what card she chooses. So we're going to just eliminate that. But now the question says, find the probability that Mr. Flowers will win. So let's go ahead and look at what Miss Ellington has to do. Then we're going to look at what Mr. Flowers has to do. So Miss Ellington, the probability, what do we want here? Ellington, we want, she's tossing a coin and hold on, Miss Ellington, she has to get an even number. So we want the number 2, 4, or 6 out of all numbers. And we want heads out of all sides. Okay? That's what we want for her. Flowers, if she's getting even, he gets odd. So we want a 1, a 3, and a 5 out of all numbers. And tails out of all. All right, so here's the bridge map that would show us what Ellington's probability is. Here's the bridge map that would show us what Flowers. It's asking about Flowers. So we're just going to get rid of that one and come over here. So that's 3 out of 6, which is 1/2. And tails is 1 out of 2, which is also 1/2. When we have multiple events, 1/2 times 1/2 is 1/4. So 1/4 is his probability. So we'll come right over here. 1/4 equals 0.25, which is 25%. But we don't need hers. So let's look at that one more time and just talk about it a minute. It gave us what Ellington needed. Well, she's tossing a number cube. So that number cube is going to be 1, 2, 3, 4, 5, and 6. Those are our outcomes for the number cube. Tossing a coin, we've got heads or tails, right? So for Ellington, she needed a 2, a 4, a 6, and heads. Flowers, so this was Ellington. Let's mark her out. So everything that was left here is what Mr. Flowers needed. And that's what we showed over here on this bridge map. And again, that sentence right there was irrelevant because it said no matter which card is chosen. I'm going to tell you now, be sure you can work that problem. Be sure you can work that problem. The University of Georgia football team has several different uniforms. The coach can choose from 3 colors of jerseys and pants: silver, black, and white. How many jersey pant combinations are there? We can do more than one thing here. On this, we're looking for combinations. Remember, combinations is going to be a table or a tree map, or you could do a list. But we're going to look at the table or a tree, okay? I'm going to do a table and a tree map, a tree diagram for you to see on combinations, all right? A sum of 3 is also considered a combination, all right? And combinations are going to be tables or trees. So on our table, we have jerseys and pants, all right? So I'm going to flip my paper. I'll tell you what I'm going to do. Let's come right here and put C back. And we're going to flip this over. This was number 4. That was number 4. Let me change up our colors so we don't get nothing confused here. All right. And this is number 6. number 6. So we have jerseys, and pants. Our jersey colors are silver, black, and white, and our pant colors are silver, black, and white. So we got silver, black, and white. Silver, black, and white. So now let's write in our combinations. Silver, 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 black, silver, white, black, silver, black, 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 white, white, silver, white, black, white, white. All right, so our combinations for these, the combinations are found here. Are the combinations. The combinations are found inside that box. These are all the different combinations. Those are all the different combinations. And so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 different combinations. Now, some of you may have preferred to do a tree. So let's look at this again. This is jersey, silver, black, and white. Then we have pants, silver, black, and white. And each one of these has to get a silver, black, and white. And so when we come out here and write our combinations, we have silver, silver. Can you see that? Silver, black, silver, white, black, silver, black, 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 white, silver, white, white, silver, sorry. White, silver, white, black, white, white. Let me fix that one. White, silver, white, black, white, white. So our combinations, if you drew a tree map, would be right there. And we still have 9 combinations. This is an or. You do not have to do both. You can choose which method you prefer. Okay? So either one of those would work. But either one of those works, and we found that there are 9 combinations. There are 9 combinations. A drawer contains 3 pairs of pink socks, 2 pairs of blue socks, 1 pair of white socks. What is the probability of choosing either a pink or white pair at random? Okay, so we're reaching in, we're drawing a pair of socks. This is one event. One event. So if that's one event, our bridge map's going to look like this. And we want pink or white out of all socks. Our all, 3, 2, 1. That's 5, 6 in all. We have 6 in all. So pink, there were 3 pair. And white, there was 1 pair. So that's 4 out of 6. And when we put that in our calculator, that is 2/3. And then we change that to a decimal, 0.67. We're going to round that to 67, which would be 67%. And we will call that likely. Mr. Queen is developing a probability simulation and has created this table. He determines the number 3 will measure his outcome. What is the experimental probability of getting at least 1 3 in a trial? So what we're doing now is we're going to go through here and we're going to look at how many different trials have at least 1 3. So there's a 3 there, a 3 there, a 3 there. There's no 3 there. There's 1 3 there. We're not circling all the 3s. We're circling just one, at least one. There's a 3 there. None, 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 none. So these are the trials that have at least 1 3. We're not circling all the 3s, just at least one. So trial 1 had at least 1. Trial 2 had at least 1. Trial 3 had at least 1. Trial 5 had at least 1. And trial 6 had at least 1. Okay? So to find the probability, this is what I did, what I got over all I did. Well, I got 1, 2, 3, 4, 5 trials that had at least 1 3. How many trials did I do? 10. 5 trials had at least 1 3. 10 trials. So this is at least 1 number 3. And this is all trials. I forgot to write that before we started. That's all trials. 5/10 simplifies to 1/2, which is 0.5 as a decimal.
I know you're in here parking thief.
All right, guys, that was Miss Purvis popping her head in here this morning to say good morning, get her a cup of coffee. So, let's see, where were we? We had just done our simulation, so I had to pause the video because she slung my door open, but let's keep going. Number 9, she's got a few more. Marion draws an M&M from a bag. He records the color and puts it back in the bag. He does this several times and records the results in a table. What is the experimental probability of choosing a yellow M&M? All right, experimental probability. Now remember, our experimental probability, what I got over all I did, and it's asking for of choosing yellow. So we want this right here. It's asking for choosing yellow. So this is what I got over all I did. What we want yellow out of all M&Ms. We had 6 yellow. Our all M&Ms is all of this. Okay? So that we don't make a careless error, because you know I can do that in a heartbeat. 52. In all, we had 52. Okay? So that's 6 out of 52. And let's go ahead and put this in here. 6, 52, enter. That's 3 out of 26. Hit our conversion key. And look right here, 0.115. That 5 is going to make that 1 a 2. So that's going to be 0.12, which is 12%. Move that decimal 2 places to the right to make that percent, or you can put in 0.12 times 100, 12%. Multiply by 100 to get your percentage. What is the probability of rolling a number greater than 4 on a number cube? The probability of rolling a number greater than 4 on a number cube. Okay, first, this is one event. Okay? You explain your reasoning. So, I'm going to just start off explaining by saying this is one event. I am finding, sorry, I can't spell, finding the theoretical probability. Now, theoretical probability. Theoretical probability. What should happen? We haven't done an experiment here. We're not doing anything. So, this is just what should happen. So, this is our theoretical probability. I'm finding the theoretical probability. Theoretical probability. So, let's just do our bridge map right here for our theoretical probability. I need what I want over all I have. All right. All right, I'm going back. I paused it and erased because I need to set up the ratio. What I want over all I have. Now, we also need to keep in mind that this is favorable over total. Okay? Now, you don't have to, and how you word this on your test is fine, but I'm giving you a good bit of information to put in there. I'm finding the theoretical probability. I need to set up the ratio, what I want over all I have. What do I want? All right, let's come up here and think about our number cube for a minute. A number cube. A number cube is 1, 2, 3, 4, 5, 6. It has the outcomes 1 through 6. And I want a number greater than 4. So over here, back to our bridge map, we're going to put in, what do I want? I want a number greater than 4. What are those numbers? 5 and 6. So I want the number 5 and the number 6 out of all numbers. There are two, number 5 and 6, there's 2 numbers greater than 4 out of 6 numbers. That will simplify to 1/3. So the probability here is 1/3. Now, if you have a question on the test, and you know that if this is the extended response on your study guide, it's going to be the extended response on your test. You know that. You need to know how to, and you can take my explanation and come up with your own. These are your outcomes. These are the outcomes on a number cube. Outcomes is a good vocabulary word. Here's vocabulary. Outcomes is a vocabulary word that one event, theoretical probability, favorable over total outcomes, ratio. Those are all the math vocabulary, a lot of the math vocabulary that I'll be looking for. Do you have to have it all? No. I need to just have a good explanation letting me know that you understand. The math is all right here. This is the math that I would be looking for. Okay? The sample space illustrates spinning 2 different spinners. Determine the total number of possible outcomes for spinning spinner 1 and spinner 2. Okay, so let's write our outcomes out here. Let's write our outcomes. So we've got, for spinning spinner 1 and spinner 2. So we have a 1, 4, a 1, 5, a 1, 6, a 2, 4, 2, 5, a 2, 6, a 3, 4, a 3, 5, and a 3, 6. These are our outcomes. The possible outcomes here are all right here. Those are all of your possible outcomes. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 possible outcomes. A bag contains 15 white marbles, 5 blue marbles, 10 green marbles. Kelly chooses a marble from the bag without looking. Determine the probability she will choose a white marble. This is one event. One event. So, what do I want? I want white. Out of all marbles, we have 15 white, 5 blue, and 10 green. So that's 10 plus 5 is 15 plus 15. So I have a total of 30 in all. I want 15. I want white, which is 15 out of 30. 15 out of 30. Put that in your calculator. Now I know that 15 out of 30 is 1/2, and some of you might know that too, and that's good to know, but we're not going to take any chances of making a careless error, okay? Hit our conversion. That's 0.5 as a decimal, and 50%. And it asks us to show our answer as a decimal, and so here's our decimal answer, okay? Alrighty. 13. What is the probability of rolling even number from a number cube? Show your answer as a percent. Well, we know that a number cube has 1, 2, 3, 4, 5, and 6 are your outcomes on a number cube. It has a total of 6 outcomes. What do I want? I want the number 2, 4, or 6 out of all numbers. So that is 3 outcomes out of 6, which is 1/2, 0.5, 50%. It said show your answer as a percent, and there's my percent. Coach Smith flips a coin to decide who will start the game with the ball. Head means home. We'll start with the ball. Tail means the away team will start. Choose the vocabulary word that best describes the home team's chances of getting the ball. Well, certain would mean it was 100%. If you're flipping a coin, we already know that percentage-wise we're looking for 50%. Okay? We're looking for 50%. We know that they have an even chance. We also know that it can be as likely as not. So let's look at most likely. It's not going to be most likely, but most likely it's going to be somewhere between 75 to 99%. That's just a rough estimate. Not likely would be somewhere like 10% to 49%. Or so, on the other side of 50%. Now, even chance and not as likely as not are not here, but all we have left is neither likely nor unlikely. what this is saying is neither likely or unlikely means that they have an even chance. This is another way to say even. This is another way to say a 50% chance. Okay? So put that in your brain for tomorrow. All right. So pause the video, go slow, go back through this more than once, and I can assure you that if you can successfully do this study guide and your mixed practice that we did, you will do well on your test.